All right, let's dive into a topic that feels like it's pulled straight from science fiction. But, surprise, it's actually happening in labs right now. We are talking about the wild science of teleportation. Just picture it for a second. No more airports, no more long flights. You step into a machine in Delhi and blink, you're in Tokyo. For as long as we can remember, that's been the ultimate sci-fi fantasy, right? But is that all it is? A fantasy? Well, as it turns out, the reality is way, way stranger than the fiction. So yeah, let's start with what we all picture from the movies. You know the scene, right? A swirl of lights, some cool sound effects, and poof, someone reappears thousands of miles away. It's a fantastic idea for sure, but it sets an expectation that real science is approaching in a totally different, and honestly, a much more mind-bending way. Okay, so here's the first big twist. The teleportation that's happening today, it's not about moving stuff. It's not about breaking down a person atom by atom and shipping them somewhere else. The real breakthrough, the actual magic, is in moving the information, the perfect, exact blueprint of an object from one place to another. So really get how this works, we have to go on a little trip into the strange and wonderful world of quantum mechanics. And to help us out, let's use this idea of quantum twins. The whole thing hinges on a principle called quantum entanglement, which is one of the weirdest and coolest ideas in all of physics. It's this bizarre, invisible connection where two particles get so deeply linked that they basically act like one single object, even if they're on opposite sides of the universe. I mean, this connection just breaks all the normal rules. Imagine you have our quantum twins. You keep one here on Earth, and you send the other one all the way to Mars. Now, if you look at the particle on Earth and see that its spin is up, you know instantly that its twin on Mars has a spin that's down. Instantly. There's no travel time for that information, it just knows. This whole connection is so immediate and so profound, it's almost like it's breaking the laws of physics as we know them. It's like these two particles have their own private, faster-than-light chat line, just whispering secrets to each other across the cosmos. So we have these mysteriously connected twin particles. Awesome. But how do scientists actually use this spooky link to teleport something? Well, it's all about recreating a blueprint. The easiest way to think about it is like this. Imagine you've built an amazing sandcastle. Now, you're not going to physically scoop up all that sand and move it. No way. Instead, you're going to send the instructions, the blueprint for that exact sandcastle to a new beach, where a brand new, identical castle is built from fresh sand. And here's the kicker. In the process of scanning and sending the design, the original castle gets destroyed. It really boils down to 3 steps. First up, scan. A scientist takes the particle they want to teleport and scans its exact state, which involves one of our entangled twins. This scan, by its very nature, destroys the original. Second, transmit. The blueprint. That information is sent through a totally normal channel, think of it like an email, to wherever the second twin is waiting. And finally, step 3, rebuild. That information is applied to the second twin, and it transforms, becoming a perfect identical copy of the original particle. And let me just say this again because it's so, so important. Nothing is physically traveling from point A to point B. It is purely a transfer of information. It's a reconstruction. The original is gone, and a perfect replica now exists somewhere else. Wild, right? Now, you might be thinking, okay, this is some cool abstract theory. But it's not. This is actually happening. Scientists are doing this right now, and the progress they've made is just unbelievable. I mean, just look at how fast this field is moving. It all started back in 1997 with teleporting the state of a single little photon. By 2004, they were doing it with entire atoms. And today, get this, we are teleporting information across cities through fiber optic cables and even beaming it from the ground up to satellites in orbit. This is not just a lab bench experiment anymore. So why does all this matter? I mean, besides being super cool, well, quantum teleportation isn't just a party trick. It's actually a foundational piece of technology for the next wave of computing and communication. We're talking about things like quantum computers and creating communication networks that are literally unhackable. So, are you going to be teleporting home from the office anytime soon? No, not yet. The jump from teleporting a single atom to the trillions upon trillions of atoms that make up a person is, well, it's astronomical. But that doesn't make what's been achieved any less of a monumental step forward for science. It's a huge deal. And that's really the heart of it, isn't it? every one of these experiments is teaching us more about the fundamental rules of our universe. They're pushing us closer to a future that could look radically different from our present, a future where distance itself might just stop being a barrier at all. So the next time you see teleportation in a movie, just remember this. What was once pure, unadulterated fantasy is now the beginning of a very real and very, very strange new chapter in human history. The future isn't just on its way, it's quantum.